For the next couple of days, we're going to actually take a look at solving equations. So these two sections should feel very familiar to you. We're going to start very simple equations that we're going to work with. Solving equations is built around the idea of inverse operations. That is to say, we want to undo all operations until we have the variable alone on one side of the equation. So our goal is to isolate a variable. Now, the types of equations that we're going to work with today as we start are called one-step equations. All that means is that we only have to do one thing in order to get to the solution, one operation. So as you take a look at the first problem, you see the x, and there's only one thing that's happening to it on the same side of the equation that it's on. In particular, on this one, we have an addition of the number 3.2. So the inverse operation of adding would be subtracting. So the way we undo the addition of 3.2 is that we subtract a 3.2. So that will allow us on the left-hand side to add these two together to be 0, right, because they are inverses. I have the x on the left, and then 4.6 minus 3.2 is 1.4. And we're done. Okay. What about the next one? What is happening to the side of the equation that has the variable? How is the y being affected? Subtraction by 8, right? So what is the inverse of subtraction? Addition. So the way that we remove the subtraction of 8 is that we add 8. Anything we do on the left, we have to do on the right, and vice versa. So on the left, we have 5 plus 8, which is 13. On the right, the 8s and a negative 8 have added to 0, leaving us with y. It's perfectly fine for you to leave this written as 13 equals y. If that bothers you, you can rewrite it as y equals 13. That's fine too. It does not matter. Now, both of those were, well, the first one was a decimal and the second one was whole number. But we can do this with any type of number. So as you take a look at the third one, you see fractions. But you're still seeing the same types of operations that are affecting the variable. Namely, we have a 2/3. So that 2/3, while it's not written in front of it, is a positive 2/3. Which means the 2/3 inverse operation of positive 2/3 would be negative 2/3 or subtraction. So I have subtraction of 2/3. So on the left, those cancel, leaving me with z. But on the right, we're going back to things that we've done earlier, which is combining fractions. So I'm going to write it out to the side, just because sometimes it's easier to see it written linearly instead of stacked. I have 3 halves minus 2/3. So what do I have to do in order to be able to add, or subtract in this case, these two fractions? You're right, I need common denominators. And what will the common denominator be for the 3 and the 2?
6.
Yeah, it'll be 6. Okay, so you're thinking about multiplying? There's no multiplication here. So I can't reduce along a diagonal. I could if I were multiplying, and we might have that happen in the future where we're multiplying or dividing to get rid of a fraction. But here we're adding and subtracting, so I can't. Anytime we're doing addition and subtraction, it's common denominators. So I need them both to be the same. They have nothing in common, so we multiply them by each other. Okay, so on the top I have, on the first fraction's top, I have 9 over 6. What's the second fraction? 4 over 6. And if I subtract 9 over 6 minus 4 over 6, what will I get? 5 over 6. And that's what would go right here is 5 over 6. And you're welcome to do sort of the supporting work to the side so that it's not kind of cluttering up the progression of your equation if you would like, kind of like we did on the screen. So z is 5 over 6. So problems 1, 2, and 3 all involved what happens when we have a number added or subtracted to our variable. 4 is different. How are the variable and the other value, the 2 to 4, connected here? They're multiplied. Okay, so you can't subtract 4. That's not going to do you any good. All right? We have to do the inverse operation for what we have there. It's multiplication. So what is the inverse operation for multiplication? Division. So in order to undo multiplying by 4, we are going to divide by 4. Now 18 divided by 4 can be written a couple of ways. If you reduce it in its fractional form, 18 and 4 are both divisible by 2, and you could have 9 halves. That's perfectly fine. It also has a really nice decimal form. So if you were to grab your calculator and do that, instead of thinking in terms of fractions, you would end up with a 4.5, and that's fine too. What's not fine is if you end up with a fraction that has things that are not terminating. 4.5 is terminating, which means it ends, right? But if you had ended up with the fraction, say, get up one, maybe like 5, how about 10? 10 over 6, it's a good example. And you reduced this one with fractions, you would end up getting 5 over 3 because they both divide by 2. But if you put this into your calculator, it's going to tell you this. And it's going to keep going like this at the end. Okay? So it's not appropriate if you're working and you like to use decimals for you to write that answer or this answer or even for the moment this answer. We're not working with repeating decimals. We're working with the simplified exact expression. So in a case like that where it doesn't end terminating, we want to use the decimal. We don't want to use the decimal expression. We want to use the fractional expression. Okay? So our example, we had options because 4.5 is terminating. How about number 5? How are the x and the 7 related on this problem? Yeah, it's division. So what is the inverse of dividing by 7? Multiplying by 7. So we will multiply both sides by 7. Now the whole point is that the 7's on the left cancel, leaving me with an x. And on the right I have 4 times 7, which is 28. Now every single one of these that we've done, you could check your answer if you wished. How could you check to make sure the answer that you have is correct? Plug it back into the original equation, right? So for example, on this one, x is 28 is what I believe that it is. If I'm right, then it should be true that 28 divided by 7 equals 4. And it does. So our answer checks out. So you can always check your answer on these problems. How about number 6? How is my variable related to the value next to it? Yeah, it's multiplication. So what's the inverse of multiplication? Division. So I will divide by -2. X on the left. What is 3.8 divided by -2?
I have no clue.
What would 38 divided by 2 be?
1.8.
Close.
1.9.
1.9. You're really close. Yeah, it's 1.9. So, and I'm missing something.
It's negative.
It's negative. So dividing a positive by a negative, I get -1.9. And if it were messier or bigger and so forth, where doing it in your head becomes unreasonable, you can always check your calculator to do so. Okay, so the first 6 examples were all what we call one-step equations. I only had to do one thing to solve. Sometimes equations take more than one step. We'll generally call them multi-step equations, but they might have 2 steps or 3 steps, something like that. But they're multi-steps. So on number 7, not only do you see a 4 there, but you also see that the x has a negative in front of it, right? 2 things. And there's often not exactly one way to solve the problem, but there may be one way that seems more natural than the rest. So on this one, I think probably the most natural thing to do is to move the 4 first. Now it's important to remember that the 4's sign is still a positive 4. So how do I remove the positive 4? I subtract 4. So So I know there's a subtraction sign next to the x, but there's not a subtraction sign next to the 4. So don't let that, sort of throw you. Of course, on the left, the 4 minus 4 cancels. I do still have the negative x on the left. And then on the right, I have 7 minus 4, which is 3. Now, I'm not quite done because I do still have a negative, right? So you can think of this in one of two ways. You can eliminate that negative by either dividing by -1 or by multiplying by -1. It doesn't make any difference because it's plain old 1. Multiplying and dividing by 1 don't change the value. So I'm going to write it as division by -1 for no particular reason. And then 3 divided by -1 would be -3. Yeah, so there's another option. Let me show you one more thing that we could do here instead. Okay, so is everybody good with its x is equal to -3? Okay, the other way to do the problem, Isaiah, would be to move the x. Was it a 7? So if you don't like the fact that x is negative, that is to say it looks like x is subtracted, right? You could add the x to the right side. So you have 4 on the left, and you have 7 plus x on the right. And then what would you do with your 7? You'd have to subtract your 7. So you still end up with a two-step equation. You still end up with x equal -3. But you definitely have that as a secondary option. Either one will work. Let me comment about number 8 before we get started. There are two things that are happening to x here. What are the two things? Multiplying by 6, adding 2. Yeah, two things being affecting the x. So when we did order of operations, we talked about the fact that when we're simplifying something, we work from the inside out, right? Y'all know what I'm talking about, right? Simplifying order of operations, we do parentheses, exponents, multiplication, division, addition, subtraction. We work from the inside out with order of operations. When we're solving equations, we work from the outside in. It's backwards. So we start with the things that are the least connected or attached to the x. So which one is closer attached? Is it the addition of the 2 or the multiplication of the 6? Yeah, so multiplication of the 6 is more closely attached, which means we will subtract 2 as our first step. It's the further away of the two operations. So I will always do it in sort of the backwards of the order of operations. I will subtract my 2 first. So of course these add to 0, leaving me with 6x. 14 minus 2, 12. Then what? Divide by 6. And what will x equal? 2. And just for fun, since we're at one that's nice and easy to check, if you wanted to check it, take the 2, you put it back in. 6 times 2 is 12, plus 2 is 14. It is, in fact, the correct answer. Number 9 has two different options for how to solve it as well. One option is actually a 3-step, and it's probably the most natural one. So if you were seeing this problem for the first time in your homework, what would your first inclination of what do I do first be? Zion, you're thinking like me. That's not what most people say. Most people look at this and they say, I'm going to distribute the 3. Okay? So I actually heard a smattering of both of those answers. So we're actually going to do it 2 times. One time we're going to divide by the 3 as our first operation, and one time we're going to distribute the 3 as our first operation. Okay? So Zion, since I heard you say divide by 3 first, that's what I'm going to do first. If I divide by 3, I have a 2-step operation. So if I'm thinking about like what's furthest away from my variable, the w, it is the multiplication by 3 on this one. So dividing by 3 would fit with that sort of a description. The 3's would cancel, leaving me with w minus 7. What's 18 divided by 3? 6. And then what would I do? Add 7. 6 plus 7 is 13. That's the quickest way to do this problem. Most of the time, I see students do it from a different perspective. So instead of this, they take the problem and they distribute the 3 through, which is totally fine. 3w minus 21 equals 18. Is everybody good on that step? Okay, so if you've distributed it through, which you totally can do, what would be your next step? Add the 21. All right, so what's 18 plus 21? Yep, 39. And then what? Divide by 3. And what is 39 divided by 3? 13. That was a 3-step process, but it was plenty straightforward too. So either of those ways are perfectly reasonable. Number 10 is actually missing a part of the directions. I thought I got this fixed. Does it say something on your paper, or does it still look like this on mine? Yours looks just like mine. Okay, so I think maybe I got it fixed, but after the thing printed. Okay, so what there should be here is there's an additional part of the directions that should be printed in. So the additional part of the directions should say this. So just put yourself a note that this is part of the question. It says y equals 7. So the question actually starts out looking like all of that, okay? It looks like z equals 4y, y equals 7. That's the question starting out. It just got left off. So if z equals 4y and y equals 7, what do you think I do? Put the 7 where the y is. Some of you are jumping to what you would already do, which would mean then multiply. And 7 times 4 is 28. So a few of your questions toward the end do this kind of a questioning set where they actually give you the value of one of the variables. Any questions on that?
What did you do?
Well, there's this part was just missing. It should have been typed in there. It should say y equals 7. So all we're doing is we're replacing the y with 7.
That was part of the problem.
Yeah, the y equals 7 is part of the actual problem.